question 18 from your text gives us this nice nonlinear system here. You'll notice both equations have three types of terms. We've got some xy's, some y squareds, and some numbers. And this one's nice in that they're already in the same form. They're lined up. We've got the xy's plus the y squareds equals a number. Okay, now I do need to strategize a little bit on which of the variable terms I want to eliminate. Notice, if I eliminated the y squareds, that wouldn't be very helpful. Because if I eliminated them, I'd still have xy's, I'd still have two variables. It would be one type of term, but it would still be two variables. On the other hand, if I eliminate the xy's, then I'm just going to have y squareds and numbers. That's one variable I can solve. So I want to try to get rid of the xy's. Since 4 is a multiple of 2, I can keep that first equation the same. 4xy plus 3y squared equals negative 9. I'm going to multiply this equation by negative 2. That's going to make this negative 4xy, so that I've got the opposite number of xy's. Then minus 2y squared is going to equal positive 10. Okay, that sign changes too. So when I add the left sides together, the xy's cancel out. I'm left with 1y squared equals 1. And so that means that y is plus or minus 1. Now, you may very well be comfortable going straight from here to those two solutions. If you were at all tempted to say just y equals 1, remember what we're doing here is we're taking the square root of both sides, but the square root of y squared is the absolute value of y, and so y is plus or minus 1. All right, each y value should have a companion x value. So let's see, if y is equal to 1, now I can pick either of the equations that has both variables in it. I think I'm going to pick the second one just because it has smaller coefficients. So let me start by just copying that down. 2xy plus y squared equals negative 5. So that becomes 2x times 1 plus 1 squared equals negative 5. 2x plus 1 equals negative 5. 2x equals negative 6. X is negative 3. So I'm going to just create a box here for my answers. To make it super clear that these two go together, I'm just going to write them as the ordered pair, negative 3, 1. All right, let's see what happens if y is negative 1. So again, 2xy plus y squared equals negative 5. That becomes 2x times negative 1 plus negative 1 squared equals negative 5. So that's negative 2x plus 1 equals negative 5. Negative 2x equals negative 6. X equals positive 3. So I'm getting 3, negative 1. Now, once we had the y values, we could use either equation to figure out x. And we only had to use one. But I will point out, it's pretty quick to plug into the other one just to confirm. And sometimes you can catch a careless mistake if you plug into the other equation and it doesn't work. So let's just see. If x is negative 3 and y is 1, that's going to be 4 times negative 3 times 1, negative 12. 1 squared is 1, so times 3 is 3. Negative 12 plus 3 is negative 9. This one checks. Let's check this one. 4 times 3 times negative 1, again, that's negative 12. Negative 1 squared is still just 1 times 3 is 3. Negative 12 plus 3 is still negative 9. So they do both check, and it's a lot quicker to just plug in and confirm that they check than it is to do the entire problem again. So that can be a very quick way of looking if you feel like, I think I did things right, but just want to be a little bit more confident before I submit for a grade. Plugging back in, you can sometimes catch some careless errors.